Hello, Honors Chemistry, and welcome to Lecture 4, Operations with Units. So in the previous lecture, we talked about how we can do operations with pieces of scientific notation. Now we're going to talk about operations with units, right? So obviously, like we said in Lecture 1, units are integral to everything that we do in chemistry, right? Because almost everything that we're going to use is a measurement of some sort, and we need to know what are we measuring, right? And what's the unit associated with it, right? That's what the unit tells us, right? So for example, when we look at this stick, well, what looks like a stick, right? Let's say that this has a length of, let's say it has a length of 2 meters, right? And that is a length, right? Meters, one-dimensional measurement, right? We could use a ruler to measure that. Here, though, now we have a square, right? 2 meters by 2 meters. So the length of each side is 2 meters, right? So that's the length of this side, and this is the length of that side. But I can find the area by taking my, because it's a square, I can go length times length, right? Which equals length squared, right? Now, if I solve for that, what that means is I have 2 meters times 2 meters. And just like when we talked about scientific notation, right, we carry everything, right? Which means I will take my 2 times my 2, which is going to give me 4. And then I'm going to take my meter times my meter, which is going to give me meter squared as my unit, yes? Which should make sense because area is measured in units squared, right? And then if I come over here to my cube, right? So I have 2 meters by 2 meters by 2 meters. So the lengths are all 2 meters. But if I know that I have a cube and all the things are 2 meters, I can find the volume by taking length times length times length, right? And that would give me my volume of this cube, right? And yeah, it is expected that you can do basic volume formulas, right? You just finished geometry, and these are things you should be able to do, right? So volume will equal 2 meters times 2 meters times 2 meters, which again, will multiply all of our 2's. So 2 times 2 times 2 is going to give us 8. And then we've got meter times meter times meter, which gives us meter cubed, right? Which should make sense because volumes are units cubed, right? Because it takes into account 3 dimensions, right? Now, going on to other things that should be familiar to you, right? Let's say that we have an irregular solid, right? This hunk of gold right here. And we sure would like to find its density. You would think to yourself, density equals mass over volume, right? That's what you learn in middle school somewhere, right? Density equals mass over volume. So we need to find the mass of this hunk of gold. Check, right? And the mass is equal to 51.842 grams. And I'm going to divide that by my volume, right? And this is how are we finding the volume in this experiment on this page? Right, we are doing the volume via water displacement, right? And it doesn't have to be water, right? Any liquid that is displaced, but if this is my final volume reading, and this is my initial volume reading, note that they've estimated one place beyond the smallest graduation being to the ones, so they've estimated to the 10th place, right? So anyway, final volume, initial volume, how do I find the volume of the gold piece? So we're going to do the difference between the final volume and the initial volume, which is 19.8 minus 17.1, which is going to give us 2.7 milliliters, right? Which means that when I do this math, right, so same thing, right? We're going to divide those numbers. So we're going to take 51.842 and we're going to divide that by 2.7, and that's going to give us the numerical part of this answer, right, which is going to be 19.2. But then we have to take into account the unit, right? We have grams on top of milliliters, grams on top of or divided by or per, right, milliliter. And that's how I get grams per milliliter or mass per volume, right? Because I take mass divided by volume. Yes, like that's how we get the units, right? Okay. What we're going to do now is we are going to do some practice, pause, work them out, and check them depending on your level of confidence. Check after each one or after the whole thing, where the units must follow through and you should have units at the end for your answer. All right, good luck. Okay, so we have a car. It travels 150 miles in 2 hours. Speed, right? So then we would say to ourselves, well, what is speed, right? Speed is, right, distance per time, right? So, what's my distance? 150 miles. And what's my time? 2 hours and 38 minutes. 2 hours and 38 minutes, and we've got to turn that into one thing. I don't know why I gave you that. You know what? Let's just pretend that says 2 hours. And then it would just be 150 divided by 2, which would give us 75 miles per hour as our final unit. Yes? Note that this, we could turn that into, and we could do it, right? We could say 38 minutes per every 60 minutes, right? And we could figure out what that is. So 38 divided by 60, right, would give us 0.633. So if we wanted to be really thorough and do this well, we would say 150 miles over 2.633 hours. Yes, does that make sense? And then we could come up with that speed, okay? Just, that was more than I was meaning to ask of you at this moment. All right, next one says a student dissolves this much sucrose in this much water, right? So this is a measure of mass, right? This is a measure of volume. And it says, what is the concentration of the solution reported as grams of sucrose per milliliter of water? Okay, well, so the problem tells me I want to solve for concentration, which is grams of sucrose per milliliter of water, right? So if we dissect that, that's what it's telling us. It's saying find the concentration, where this is our concentration, and it wants it in units of grams of sucrose per milliliter of water. Per means, right, so per just means divided by or is equal to, right? And so that's all we got to do, so we got to set that up. So 275 grams of sucrose for every 325 mils of water. We will not leave things as a fraction. We will divide them out. So 275 divided by 325 is going to give us 0.846. And the unit is grams of sucrose per milliliters of water. Yes? Note that when we actually start class, we'll talk about how many decimal places or how many places to put in our final answer. That's something we'll clean up later. All right, next one says the dissolving of 28 grams of stuff releases 500 joules of heat. What is the heat of dissolving in joules per grams of solute? Okay, so do you know what heat of dissolving is? I don't know. Probably not. But it doesn't matter if you know what it is. We know that the final units need to say joules per gram of solute, right? So here is, look at that. We've got a joules, right? 500 joules per gram of solute. Solute is the thing we are dissolving. So that's 28 grams of solute. And again, we just need to do the math, right? So we'll divide the numbers. And that's going to give us 17.9. Actually, we're going to round that to 18. 18. And then this unit stays, right? Joules per gram of solute. Ta-da! All right. Last one says we have a cylinder with a height of 5 inches. It has a radius of 2 inches, and we would like to know the volume of the cylinder. Oh, well, this one's easy, right? You've been doing these. You were doing these just a few months ago, probably, right? So, volume of a cylinder is, right, pi r squared h, right? And lo and behold, lucky for us, all of our units are already matching, right? If they weren't, we would have to fix that first, but they are. So volume equals pi times r, which is 2 inches, squared times h, which is 5 inches. And then we just have to do the math there, right? So again, we're going to take pi and multiply that by our 2 inches squared, and then multiply it by our 5. And that's going to, in terms of numbers, give us a 63. And then we got to think about what happens to the unit, right? If I have an inch and I square it and multiply it by 1 more inch, I come up with, correct, inches cubed, which makes sense because it's a volume, right? So that's the beautiful thing about chemistry, is that the units should make sense, right? There is always, almost always, going to be a logic and a reason to what kind of units we are given and what kind of units we end up with, right? And that's one of the ways we can always double check what we've done to make sure it makes sense and that our answer is logical. All right, thank you for listening, and be good, and I will see you soon. Bye.